Part 2, Math 14-15, exam review. It says a farmer has a total of 300 yards of fencing. He wants to enclose a rectangular field and divide it into 2 plots with a piece of fencing inside that's parallel to these sides. So what they're saying is, we're gonna call this side X and this side Y. So this is an X by Y rectangle. But we want to put a fence that's parallel to these 2 sides. So in other words, we have 300 yards of fencing. So the perimeter, we're going to add up all of these sides. So we have X, X, and X, which is 3X plus 2Y. And we have 300 yards of fencing. We want to express the area as a field of the field as a function of X. So what you're going to do, we want to look at the area. Area is equal to length times width, X times Y. So if you solve this equation for Y, if you get Y by itself, you end up with 300 minus 3X is equal to 2Y, and then divide by 2, everything. 300 divided by 2 is 150, minus 3 halves X is equal to Y. So now you're going to plug this in.
Students who signed up to ride the bus home after tutoring today, you must board the bus no later than 3:05 outside
This
of
is
the
also
college.
equal to Y. So we're going to write this as a function of the area, so X times 150 minus 3 halves X. And that is, the answer would be D. So you start with 300 yards of fencing. This is X by Y, but we want to put another strip that's parallel to these 2 sides, so they're all 3X, they're all X. So 1X plus 1X plus 1X is our 3X, and then 2Y. Set that equal to 300, divide, or solve this for Y, and then replace Y in here for area, and you'll get the correct answer. Next one, number 36. We did these in class, but I'll go through them again really quick. The zeros are 3, not -3, but 3, -4, and 5, which is B. The opposites of these. This polynomial, they want to know where it has a 0 at 2 with the multiplicity. It'd be right here. So the multiplicity is 3 at 2. Number 38, the real zeros are -5. X squared minus 1 equals 0. X squared equals 1, square root of both sides. X is plus or minus 1. And this one, if you set this equal to 0, X squared plus 9, if you set that equal to 0 and subtract 9, square root of both sides, this is not a real 0. This is 3i and -3i. So the only real zeros are 1, -1, and -5, which is C. Okay? For number 39, you're going to want to do your P over Q test, but looking at your answers, it looks as if 2 is going to be one of the answers. So if you do synthetic division, and you do 1, -4, 6, -4, bring down the 1, 2, add, you're going to verify that 2 is a 0. So what's left here is x squared minus 2x plus 2. Set this equal to 0, and you can use completing the square to figure out the other 2 zeros. So to do that, x squared minus 2x plus 2 equals 0. Subtract 2. Take half of this and square it. Factor. Square root both sides. X minus 1 equals plus or minus I, and then add 1. So the three zeros are 2 and 1 plus and minus I, which would be D. Okay? So, the number 40, if x minus 1 is a factor, we could plug 1, the opposite of this number, in for x. We're gonna evaluate this for f of 1. So we're gonna plug 1 in here. So 8 times 1 cubed plus k times 1 squared minus 4 times 1 minus 2. This would be equal to 0. So 1 cubed is 1, 1 times 8 is 8, plus 1k minus 4 minus 2 equals 0. Collect like terms, this is 6 minus 6, 8 minus 6 is 2, subtract 2, k is negative 2. And that would be A. Next, for 41, you're given this picture right here. It's a polynomial where the right side is going down and the left side is going up. So if the left and the right side are doing opposite, our degree has to be odd. If the left side is going, if the left side's going up and the right side's going down, your leading coefficient has to be negative. So the correct answer would be D. We want an odd power with a leading coefficient that's negative. Even powers, the left and the right side both do the same thing. So for this one, the left side would be going up, right side, I'm sorry, other way around. This one, this is even, both left and right would be going up. This one, both left and right would be going down. For C, the left side would be going down, the right side would be going up. That would be C. For number 42, the maximum number of possible zeros would be 5. For 43, which one's not a possible zero? You're going to do factors of P, so P1 plus or minus 3 over factors of 4. So plus or minus 1, plus or minus 2, plus or minus 4. So the possibles are 1, negative 1, 3, negative 3, 1 half, negative 1 half, 1 fourth, but not 2/3. 2/3 would not be a possible zero. 41. The opposite of this and this are going to give you your asymptotes. So y equals negative 3 is your horizontal asymptote, and your vertical asymptote would be x equals negative 2. This gives you your vertical asymptote. That gives you y equals negative 3 is your horizontal asymptote. And to graph that would be D. Your vertical asymptote is here. Horizontal asymptote, negative 3. And you're in these two quadrants, 1 and 3. For 47, to find any vertical asymptote, you set the bottom, factor it, set it equal to 0, so x equals negative 1. That would be D. For 48, if the degrees of the numerator and denominator are the same, you take the leading coefficient of the numerator, which is 4, over the leading coefficient of the denominator, which is 2. 4 over 2 is 2. That's if the degrees are the same. You take the leading coefficient of the numerator over the leading coefficient of the denominator. If it were bottom heavy, y equals 0 would be your asymptote. If it's top heavy, there would be no horizontal asymptote. For 49, which of the above graphs is not a function? So you want to look and see which one does not pass the vertical line test. The one that does not pass the vertical line test is D. The one that has an inverse function is actually D and E, both of these, because they pass the horizontal line test. I would say D and E. But if you look at this carefully, it says which of the above functions, so this technically is not a function, so really the only one that's a function that has an inverse would be E. This is a function that passes the horizontal line test, so really we wouldn't include D. But D does have, its inverse would be a function. 51. They want you to add, combine f plus g. So you would add 2x squared plus 3 plus 5x minus 3. The 3's cancel out, you get 2x squared plus 5x. And then you're going to evaluate this for 2. If you plug 2 in here, 2 squared times 2 is 8. And 5 times 2 is 10, so that gives us 18. This one is a composition. We want to plug 1 into the f function and evaluate it. If you plugged 1 into the f function, 3 times 1 is 3 minus 7 is negative 4. And then plug negative 4 into the g function. Plug negative 4 here, square it, and add 3 times negative 4. You get 4. (53). This one is asking you to find f of g of x. So you're going to take the g function and plug it in for f. So in other words, 3 times 2x squared plus 1. I'm sorry, 3 times 2x squared, and then add 1. Add 1 at the end. So this goes in here, 3 times 2x squared, which would be 6x squared, and then plus 1. That would be B. Number 54 is a splitting problem. So you want to do f of g of x. So we would want to call the g function would be what's inside of this radical, so x squared minus 1, and the f function would be the square root of x. So g of x would be x squared minus 1, and f of x would be, so that would be b. So if we have two functions that are inverses of each other and 3 is in the domain, we would say that the result would end up being 3. We did this with x. The inverses would be come out to be, if you did the inverse of them, you would get x. This one's asking you what's the inverse of this function. So it says y is equal to 2x minus 4. The inverse is when you switch x and y around. And solve this now for y. So add 4, and then divide everything by 2. So 1/2 x plus 2 is equal to y. Correct answer would be C. Next one. I would like to find the inverse of this. So this says y equals x minus 2 over 2x plus 3. So the inverse is saying flip x and y. Now we have to solve for y. So I'm going to cross multiply. I'm going to say x times 2y plus 3 is equal to y minus 2. I need to get my y's together so I can factor it out and solve. So this is 2xy plus 3x is equal to y minus 2. I'm going to bring y over here. 2xy minus y is equal to negative 3x minus 2. I'm going to factor out a y, and I'm left with 2x minus 1. And I'm going to divide by 2x minus 1. So y would be negative 3x minus 2 over 2x minus 1. And the answer would be, if I bring this negative down here, I believe it would be E. So let's double check. If you swing the negative down, 57 would be, yep, E. So what I could do is factor this negative 1 out, and you get 3x plus 2. Want you to see what they did, and they bring this negative down here, make this negative 2x plus 1. And then they switched these two, they wrote 1 minus 2x. So the correct answer is E. Okay? This is a exponential function, and if you were to graph it, you would see, if you were to make a t-chart and plug numbers in for x, you would see that it looks like this. And your range is from 0, it's not going to hit 0, but it's going to be greater than 0. Now, if there's a number outside right here, this is going to be, so 0 for this one is your asymptote, and for this next one, this is going to shift 1 unit down, and now this base is the E, 2.718, but it's going to be a shift 1 unit down, so it's going to be, and actually 2 units to the left, so it'll be something like that, but y equals negative 1 is going to be your asymptote. So if they asked you what's the domain, it'd be y is greater than negative 1. That's your asymptote. Okay? The next one, if you were to plug, it's asking you for f of g of a. If you were to plug this in here, if you were to plug the g function into the f function, you would have the log base 2 of 2 to the x power. Okay? But they're asking you to plug an a in. So really, instead of the x, you've got an a. If you bring this in front, this is equal to 1, so really you just have whatever you plugged in, so A is the correct answer. The next one, 61. This is asking you to solve for this variable, which is very hard to see. I believe it's a t. It says e to the t over 6 is equal to 8. So you'd want to write this in log form. Log of 8 base e is equal to t over 6. This is a power. This is really ln 8 is equal to t over 6. So if you were to figure out what t is, you'd be multiplying 6 times ln 8 is t, which is a. Next one. Number 62, how would you solve for x? Well, you'd get both bases the same. So 8 is 2 to the third power. So 2 to the third times x plus 3 is equal to, equals 16 is 2 to the fourth power, and don't forget your parentheses, 2x plus 1. So now you're going to cross these 2's out, and you have 3x plus 9 is equal to 8x plus 4. If we subtract 3x, you get 5x. Subtract 4, you get 5. Divide by 5, x is 1. Okay, this next one is kind of tricky. To do this without a calculator, you've got bases that are different and you've got exponents, so you can't write this in log form. So you're going to take the natural log of both sides. Okay, now the power rule says to take this power and bring them in front. So you have x minus 1 times ln 3 equals x times ln 5. Okay, now we want to get ln by itself. So if you were to distribute ln, so it's x times ln 3 minus ln 3 equals x ln 5. Now I'm going to bring this x, this set over here. So x ln 3 minus x ln 5 equals, this is going to go to the other side, positive ln 3. I'm going to factor an x out, and I have ln 3 minus ln 5. And I'm going to divide both sides by ln 3 minus ln 5. So your answer is x is equal to ln 3 over ln 3 minus ln 5. The correct answer would be A. Okay. This next one, if you were to look at, this is an exponential problem, it's a log, but the base is 1/2 to the y power is x. If you're not sure, you can plug numbers in and see which one works, but it is B. The interval, which one is one where it's decreasing, and it would be similar to this where the base is a fraction. Which one has an interval decreasing? That would be E. For 66, for these log problems, you're going to have an asymptote. This is your asymptote right here. It's going to be x equals 2. And it's a vertical asymptote. X equals 2. It's what's inside here. Keeping that in mind, you're going to have an asymptote for this one at x equals -1, like that, x equals -1. And so your domain is going to be x is greater than -1. Sorry, this one. X is greater than -1. For 68, if you plug 16 into for x, the log base 2 of 16 is equal to this y value. So 2 to what power is equal to 16? And that would be 4. Okay. For 69, I'm asking you to find the inverse of this. So this says y is equal to 3 to the x power. So the inverse would be x is equal to 3 to the y power. So you'd want to write this in log form. This would be the log of x base 3 is equal to y, which is D. That would be your inverse of this. Okay? And likewise for this one, I want to find the inverse of this. So this says right now y is equal to the log base 2 of x minus 1. So if you were to switch these around, you'd have x is equal to the log base 2 of y minus 1. Now let's rewrite this in exponential because we want to solve for y. So it's 2 to the x power is equal to y minus 1, and solve this for y. So you'd add 1, 2 to the x power plus 1 is equal to y, and that would be D. 71. To solve this one, you're going to want to write it in exponential form. So x to the 1/3 power is equal to 3. So you would have to cube both sides to get x by itself. So x would equal 27. To solve 72, you're going to rewrite this as 3 to the 6th power is equal to 27 to the x power. I want to get this in base 3. 3 to the 3rd power, 3x. So you're going to set these equal to each other, and you've got 3x equals 6, so x is 2. 73, how would you condense this as a single log? Well, what you'd want to do is look at the fact that you have a couple subtractions. So these would be in the denominator. So this 3 goes here. You would cube that. And this 2 is you're gonna square that. So you've got, and they're all base 4. So it's the log, we'd have x on the top, and we have a y, we'd have a 6th power, because 2 times 3 is 6, and then times 2 to the z power, 2z, and we're going to square it, would be 4z squared, squaring both of these. So the answer I would pick would be x, I would pick letter E for that one. Okay, number 74. How would you break this one up? Well, we would write x minus 4. This piece right here is really x minus 4 to the 1/2 power. So this would be first ln x squared times x minus 4 to the 1/2 power over x plus 2 cubed. So this is going to be a sum, and then we have a quotient, so it's a subtraction. And each of these powers goes directly in front of each ln. So the correct answer would be 2 ln x plus 1/2 ln x minus 4 minus 3 times ln x plus 2. Next one, we want to condense 75. This is a plus sign, so we're going to make this a product. This would be the log base 4. We have x times x minus 12 equals 3. So we condense the left side. Now, we cannot do anything else besides write this as an exponential problem. 4 to the 3rd power is equal to x times x minus 12. Well, 4 to the 3rd power is 64. This is x squared minus 12x. Set this equal to 0, and you have x squared minus 12x minus 64. And you'd ask yourself, what times what is negative 64 but adds to be negative 12? And that would be x minus 16 and x plus 4. Set these equal to 0. So your possible answers are 16 and negative 4. But when we plug negative 4 would be an extraneous solution because this would generate a negative right here. You can't have a negative. So 16 is the only answer for 75. For 76, you would condense this one by, this is an addition problem, and we could eventually cancel these logs, but let's first condense the left side. It'd be x plus 1 times x plus 3 equals the log of 3. Now, these are both base 10, so 1 for 1 we can cancel these out. Distribute this, x squared plus 3x plus 1x is 4x. These 3's cancel. We can factor an x out. Set this equal to 0, so there's two possible answers. X is 0 and x is negative 4. But we're going to cancel out the negative 4 answer because if you plug a negative 4 in, you would end up having a negative. You can't have that, so 0 is the only answer. 77. Again, you're going to condense the left side, but it's a division problem. It's log base 2, x squared minus 1, because it's subtraction, x plus 1. Now, I know that I can factor this numerator. This is x minus 1, times x plus 1. It's the difference of two perfect squares. So these two are condensed, they're gone. So in other words, 2 to the third power is equal to x minus 1, and 2 to the third power is equal to 8, and add 1, and x is equal to 9. Correct answer is D9. 78, it's between 1 and 2. 79, what you're going to do on 79 is you're going to turn 45 into a product of 3 and 5. So in other words, 45 is 9 times 5, and 9 is 3 times 3 times 5. So if the log base 3 is equal to x, and you're gonna add, because it's the properties say if it's multiplication, you're gonna add. If this is x and this is x and this is equal to y, you have 2x plus y, which is C. Okay. Next one. Show you how to do this one. We have a compound quarterly problem. We want $20 to grow into 60. So you're using this formula. P is equal to the other way around. Write it again. A is equal to P times 1 plus the interest rate over n times t. So we want to turn $20 into 60 with an interest rate of 5%, compounded quarterly, so that's 4 times a year, and we don't know how long. So that's our formula right there. So what we have to do is get rid of this 20. So if we divide both sides by 20, you get 3. 3 is equal to 1 plus 0.05 over 4 raised to the 4t power. So now I'm going to turn this into a log problem. It would be the log, this would be the base right here. This is your base. We're going to keep it as 1 plus 0.05 divided by 4. The answer is 3 is equal to 4t. Now, the change of base formula says it's the log of 3 divided by the log of 1 plus 0.05 divided by 4. And now you're going to divide that answer by 4, which is really multiplying it by 1/4. Now, instead of log, you can use ln. So the correct answer would be ln 3 divided by 4 times ln 1 plus 0.05 over 4, which is A. It's a tricky one. Okay. Number 81. How many years does it take for an investment to double in value if it's invested at 8% compounded continuously? So you're going to use the PERT formula. So 2P equals P, we want to double. If it said triple, it would be 3P equals P times E raised to the RT power. The interest rate is 8%. 8% times T, so 0.08 times T. Now you're going to turn this into another log problem. Log, it's the base is E, 2 is equal to 0.08 times T. Well, log base E is really ln 2. ln 2 equals 0.08 times T. So if we're solving for T, you're going to divide both sides by 0.08. So ln divided by 0.08, which is D. Number 82. We want to use this is the same as the continuous formula, the one above, but we have bacteria and we want it's going to triple in 2 hours. Okay, so for this one, it's 3P it is right here. So you could use 3p, I use 3n. 3p equals n times e, it's gonna double. So the n's cancel. So we have 3. 3 is equal to e raised to the 2r power. So turn this into a log problem. It'd be the log base e of 3 is equal to 2r, which is really ln 3. ln 3 equals 2r and then divide by 2. So it's D. Questions 83 and on were done in class. So I'm going to stop here at 82, and that concludes my review. Hopefully it helps.